In Lesson 22, we'll be reviewing numerical and algebraic expressions. We'll be covering statements and sentences, which are like the fundamentals of doing word problems. And then we'll be looking at conditional equations. Now, in Part A of this lesson on numerical and algebraic expressions, those are just some definitions that you need to be fairly familiar with. A numerical expression, that could be just like a number, like a 4. Or it could be like a statement like 2 plus 5. Those are numerical expressions. They have a particular value to them. Now, algebraic expressions, those could also be numerical expressions, or they could contain variables, such as x plus 9. That could be considered an algebraic expression, or x squared minus 1. That could be considered an algebraic expression. It has variables and numbers in it. So numerical expressions, they have a particular numerical value to them. Algebraic expressions, they can be numerical expressions, or they can contain variables as well as numbers, or just variables. In Part B of this lesson, it's about statements and sentences, and like I said earlier, this is about the fundamentals of doing word problems. A lot of times in algebra, you have some problem that you have to do, and it's written out in words, but then you have to figure out an equation to help you solve that problem, and that equation is based on the words that you just read. For example, look at this sentence that I've just written. The number of fish equals the number of shrimp. So that's like a grammatical English sentence. Now we could write an algebraic sentence based on that grammatical English sentence there. And we are talking about the number of fish equaling the number of shrimp. Now, we weren't given a certain quantity of fish or a certain quantity of shrimp, so we could use a variable there. And we could say n for number. A lot of times or most of the time, we want to use a descriptive variable that describes that quantity that's in the English sentence. So the number of fish, we could say n for number, and then a little subscript f for fish, and then an equal sign equals the number of shrimp, so n subscript s. So those descriptive variables that we have used there, that helps us relate those back to the English sentence. Now, if that sentence had read the number of fish is not equal to the number of shrimp, we could have just had the same algebraic sentence with a slash through the equal sign that represents not equals. Or if we had the number of fish is greater than the number of shrimp, if that would have been our sentence, we could have had a greater than symbol in between. So pretty soon you'll be working with problems or word problems where you have to take the English sentence and turn it into an algebraic relationship. For right now, all they want you to do is kind of get used to the idea of taking an English sentence, converting that into an algebraic statement. The third part of this lesson is on conditional equations, and it would be a good idea first just to talk about what an equation is, and then we'll talk about what a conditional equation is. Now, an equation, all that is an algebraic expression that is separated by equal signs. For example, you have one algebraic expression on the left, an equal sign, and then another algebraic expression on the right. Remember, we just learned that algebraic expressions can be numbers, or they can be letters and number combinations. Now, some equations, even though they have an equal sign in between them, they are not necessarily true equations, like that second one there. 4 does not equal 6. So even though it says 4 equals 6, we know that that is not true. An algebraic expression like this, though, could be separated by another one with an equal sign, and that could be a true equation because there is a value there of x that would make the left side equal to the right side. An equation like that, x plus 4 equals 8, that's what a conditional equation is, because whether it's true or false, that's conditioned by what number you put into that expression on the left for x. For example, x equals 4, that's the only number that would work in there to make the left side equal to the right side. If we put x equals 5 in there, then we'd have 5 plus 4 is 9, which does not equal 8. So there's one and only one value that will go into that particular equation to make that a true equation. So conditional equations, they're conditioned by the value that you put in there for the unknown variable. The truth or falsity of that equation is conditioned by whatever value you substitute in. So for that example there, x equals 4, that would make that statement true. If you substituted x equals 4 into that equation, then you would have 4 plus 4 is equal to 8, which is true. Now, in a conditional equation, the value that you substitute in that makes it a true equation, that's sometimes called a root or a solution. Those are just words to get familiar with. A root or a solution. You might also hear a statement saying x equals 4 satisfies the equation. It's kind of like a personification of algebra. That equation is happy if x equals 4 is in there. That makes it a true equation or true statement. If another value besides x equals 4 is put in there, then it's not happy. It doesn't satisfy the equation. Let's look at a practice problem here. In practice problem A, what I want you to do is tell me if x equals negative 4 is a root of x squared plus x equals 12. So basically what that means is if I substitute x equals 4, or if I evaluate the left side of that equation for x equals negative 4, will it equal 12? Will it equal the number on the right? So let's just go ahead and evaluate that expression by substituting negative 4 in for x. And so we would have negative 4 squared plus a negative 4. Now that doesn't really look like it's going to equal 12, but let's just keep going here. Negative 4 times negative 4 would be 16 plus a negative 4. That's minus 4. And so that does equal 12. And so we would say to the answer for that question, 12 really isn't our answer there. Yes is our answer. So make sure you answer the question correctly. The question was, is that a root? Yes or no? Yes. So yes is our answer. Let's do one more of these conditional equation problems. Look at B. It says, does x equal 1 satisfy the equation 3x squared plus x equals 2? So what we do there is we do an evaluation of the left side of the equal sign, and we substitute x equals 1 in to the algebraic expression on the left. And so we'll have 3 times 1 squared plus 1. And so let's go ahead and simplify that. 3 times 1 squared would just be 3 plus 1 equals 4. And so 4 does not equal 2, so we would say no for this one. That would be our answer, no. But you have to show your work. You have to prove why the answer is no. So you can't just guess on these and say yes or no, or do them in your head. You need to show why it's no. So in a conditional equation, the truth or falsity of that equation is conditioned by or is dependent on what value you substitute in for the missing or for the unknown variable. Okay, well that's all for lesson 22.